Alrighty, people. We are going to be looking at functions on this lesson. And functions are very similar to relations. In fact, they're just special cases of what a relation is. The only difference is that a function will only spit out one value for every given x value. Another way to look at it is if you put in one input, you only ever get out one output. And maybe you're thinking that that's not always the case, but let's just look at examples of things that are functions and things that are not. You'll see what I mean. Okay, so three of these here, or sorry, two of these are functions, and one of them is not a function, it's just a relation. These are all relations, okay? So they're all relations, but two of them are special in that they are functions, if that sort of makes sense. Anyways, a relation is, again, is just something that relates x and y, or two quantities to each other, somehow. So these are all relating x and y, x being the horizontal axis, y being the vertical axis. And let's look at why these are all functions. So pick any x value on the first graph here, this one here, and I go up and I see that there is one y value right there. Okay, and I can do that anywhere. This x value, I get one y value right there. That's it. I can only ever get one y value. Same thing for the second graph. Okay, I pick an x value there, and I go up here, and there's one y value. I go over here to this x value, I get one y value. Even right here at x equals, what is that, 4? I go up here and I get one y value. This one is not included because it's an open dot. So there's one y value there. The same thing here. Okay, there's one y value, which is 2 over there. That's it. There's no 2 anywhere else on the graph at this x value. For something that's not a function, that's just a relation, that doesn't hold true. So for example here, okay, so here is one y value, so that's fine there. But look right here, at this x right there, there is 1, 2 y values. So I get 2 y values for my output for my one input. So this is not a function. This is just a relation, okay? If you want, you can call it the vertical line test, and that is if you can draw a vertical line through 2 points on the graph, then it's not a function, it's just a relation. So again, the vertical line test, if a vertical line touches 2 or more parts of the graph, then it is not a function. So for these two graphs here then, the one on the left is a function because no matter where I draw a vertical line, it only ever touches the graph in one spot at each of those points there. Okay? But with the one on the right, I can draw a vertical line there. It only touches at one point, but this one here touches there, there, and there. So it touches 3 points, so it's not a function. Okay? A function only has one output value. Okay, well, enough about definitions. Let's look at function notation, which is going to look a little bit different than what you're probably used to, but it's nothing really tricky. Okay, so here's an example of a function. We've seen something like this before. 2x plus 3, that's equal to y. So in other words, if I make x equal to 0, then y equals 3, because 2 times 0 is 0, plus 3 is 3. And then 2 times 1 is 2, plus 3 is 5. And I can get a table of values set up here pretty quickly. Okay, that's all a function is. Okay, it's just you're plugging in numbers and you get a number out of it. Okay, well, how we can denote that with function notation looks a little different. I can call the function something, and typically I call it f. So the function is called f. All right, and it's written in terms of x. In other words, the variable I'm using is x. F of x is 2x plus 3. So the function is called f, and it's written in terms of x. Okay, that's all it's really saying. So I'm not really doing anything too terribly different, just the way I write things looks different, okay? And then how I write the table of values can look a little different as well. In other words, instead of saying that y is 3 when x equals 0, I can say f of 0 is equal to 3. Okay, that means the function f equals 3 when x equals 0. Or if you substitute 0 into the function function f, you get the answer 3. And then likewise, f of 1 is equal to 5, and f of what is equal to 9. Well, looking at the equation on the left, or the table of values on the left, I can see that f of 3 is equal to 9. Okay, so it's just a way of writing a different, writing what x and y are, a little bit different than what you're used to. And then you might be asked, for example, to find f of negative 4, which just means what is the value of the function f when x is equal to negative 4? Well, to do that, you just substitute negative 4 in for x. That's all we're doing. Nothing really crazy here. So f of negative 4 is the function f, which is 2x plus 3. Okay, but instead of writing the x, I write negative 4. Okay, so you'll notice that this is an x there and an x there. Here I have negative 4 there and negative 4 there. So whatever is written inside those brackets there has to be written in the following equation. And so the value of the function f when x is negative 4 is equal to, well, negative 8 plus 3, negative 5. Okay, there you go there. So a little different, but nothing too crazy. Let's look at some more examples here. Okay, well here we have two different functions, and because I have two of them, I'm going to give them different names. So one is g, so g of x. The other one is f, so f of x. They're just two different functions, and I can make up a table of values if I want, just like I did before, or I can just look up specific values. It doesn't really matter. So if you're asked to find g of 5, why don't you go ahead and see if you can figure that out really quickly. I'll give you 2 seconds. So if you said, maybe in your head or wrote it down, g of 5 is equal to 5 squared. All I've done is I've substituted 5 in for x, just like I did in the original function. Okay, and so all I have to do is do 5 squared, which is 25. So g of 5 is 25. Simple. This is a little different. I'm asking you to find what value of x will make the function f equal to 13. In other words, if you want to look at it from an x and y perspective, if y is 13, then what is x? Or if f of x is equal to 13, how did you get that? What is x going to be for that? I'll give you a few seconds to think about that. Well, if we said the f of x is 13, I'm going to just say right up in the original function, 13 is equal to f of x. That's equal to x plus 1. Well, okay, how can you solve that? Well, you can subtract 1 from both sides. So in other words, x is 12. Okay? X is 12 and x plus 1 is 13. So in other words, f of 12 is equal to 13. Okay? We found x that way. Just like that. All right? Nothing too crazy. Let's look at a couple other examples here. Okay, here are two other functions. F of x is x minus 3 and g of x is 2x. And let's look at what we can do in a slightly more challenging fashion. I can ask you to find what is 2 times f of x. In other words, what you're doing is you're multiplying the entire function by 2. Okay, so we can just substitute in here because f of x is equal to x minus 3. Okay, so I'm just basically asking you to find what is 2 times x minus 3. And I can use the distributive law here and say this is 2x minus 6. The other thing I can do is I can substitute besides x in there. I can say, well, what is g of 2x? Okay, and what that means is, again, you're going to substitute in for x. You're going to put 2x there instead. So that's going to look like 2 times 2x. And so g of 2x is simply 4x. All right? And again, this function notation all does the same thing. Whatever's in the brackets gets substituted in for the variable. Okay, then for each of these functions then, well, for the one on the left, I want you to find f of x plus 6. That just means plug in x plus 6 where you see x in the function. For the one on the right, I want you to substitute x squared in for x and just write down what you get. It's not that difficult. See if you can figure it out. All right, answer's coming. So f of x plus 6, all that means is I'm going to rewrite the function right here, but instead of writing x, I'm going to write x plus 6, and then it's just minus 3. Okay, so then f of x plus 6 is just, well, x plus 6 minus 3 is just x plus 3, because 6 minus 3 is just 3. There's the answer there. Okay, and the one on the right, here's the answer. It's just 2x squared, or if you like, no brackets necessary. G of x squared is just 2 times x squared. Okay? Well, let's make this a little bit more difficult for the last example prior to the homework question. If I asked you to find g of f of 4, what am I asking you to find here? Well, what I'm asking you to do is I'm asking you to first of all find f of 4. What is f of 4? You can find out right using that function there. Once you get that answer, plug it in to the function g and see what you end up with. Okay? Give that a shot. I'll give you 3 seconds. Okay, so what is f of 4? Well, f of 4 simply means, whoops, 1 second, simply means that f of 4 is 1. 4 minus 3 is 1. So that means I'm going to substitute this into there. Okay, so that's asking me to find then g of 1. Well, g of 1, I'm just going to plug it into my other function, and so g of 1, I don't need to write it right there, is going to simply be 2 times 1. In other words, g of 1 is 2. Okay, and so if you wanted to say it the long way, you could say that g of f of 4 is equal to 2. And that's kind of your final answer. All right, here is one last question. Try this for homework. We'll talk about it tomorrow in class. Okay, I want you to try to find g of f of x all squared. That's telling you to square f of x and then put that answer into the function g. Bring that to school tomorrow. We'll talk about it then. See you later.